Hi there, my name is Michael Fudge. I'm your instructor for IST 722, and what I'd like to do with our first lecture is review SQL with you a little bit and also show you how to profile data sources. The goals of the activity today are to connect to our SQL server and explore the databases that are on there. We'll also talk about data profiling, which is how you get to know your data. Using SQL to do the data profiling is going to be the main focus. And as a result, we'll also review some important aspects of SQL that you'll need to master this course. So there's a video that I already have up there that shows you how to connect to the SQL server. And to do this, you'll need Remote Lab. So here's the information on Remote Lab. All it is a website that brokers a connection to a lab machine over the RDP protocol. So you need to have the remote desktop client either installed on your Windows machine or Mac to do this, or you need to be in the computer labs, one or the other. After you connect to Remote Lab, you want to connect to our database server, and the reason you need to use Remote Lab is because we must use the Windows authentication credentials, and you can't take your laptop from wherever you are over the summer and connect it to our domain any other way. The only way you could do that is through Remote Lab. Some of the databases that are on the server that we'll be using throughout the course, the first two that I'd like to point out. Here's some of the databases we'll be using throughout the course. Two I'd like to point out in particular are here and here. These two databases will vary based on your own net ID. Obviously there's my net ID in there. And one of them is for staging data, and the DW one is for your data mart tables. These other databases that you see here, we will use them as part of case studies throughout the semester. Some of them you will use in lab activities, others you will use as part of your group project. All the group project data is located in the external sources database. You have read-only access to all of these data sources except for the two personal data sources that you own, these two down here. All the other ones you have read-only access to. So you won't be able to create any tables in these other sources. But the external sources database here has all of the, this actually remotely connects to other databases around campus that have real-time data that we can use as part of our data warehousing projects. And we'll get into that in more detail in a little bit. Just a quick demo. I've logged into the SQL server here. I'm connected to ist-cs-dw1.80.sierra.edu. That is our data warehousing server. And one thing that you might not know how to do, because you may not have learned how to do this in IST 659, where usually every student just has one database, is how can you query across different databases. So you can see I have this IST 722 MA-Fudge DW database that I'm in now. Maybe I want to use this other database here, this stage database. So normally you can come up here and click and change that, but there's a command that you can use here, use. When you execute that command, now it switches your database. So I can do this a couple times here just to show you. So I execute this command, switches my default database. I execute this command, switches my default database. You can also query databases from within any database that you have access to. So I'm in the stage database, but I can query the external sources database. Watch. So I just queried the Remote Lab events data source from the external sources database. So again, the external sources database has a series of SQL views in it. It has no tables, it has views, and those views are pointers to various databases across campus that have been anonymized so that we can use it in the course. So you have a source of actual real data that you can use to build out your data marts that you'll be building in the course. But also these data marts will come from real external data sources. So this gives you a great opportunity to figure out the challenges associated with using live data and data from external sources that may not perform as well as you're used to. And these are important real-world struggles. So the other thing to mention is DBO. That's the owner of the database. So usually this represents the schema as well. So when you have no schema, the default schema is DBO, but you can use other schemas. And schemas are a great way to group or organize the tables and views and other structures within our databases. So what is data profiling? The gist of data profiling is using the SQL query language, mainly the select statement, to become familiar with the source of your data. And what we want to try to understand about our data is the structure, the content, its relationships, and specifically when you're looking at any set of data, what does a single row mean? What makes that row unique? We call that a business key. We're not talking about primary keys now that you might see in your tables. We're talking about amongst the data that you see, what can be used to ascertain uniqueness about that data. And this is something that you probably are familiar with when you learn data normalization. You focus on the business keys in normalization, not necessarily your internal primary keys, because your primary keys could be surrogate keys, which are made up and they don't have any meaning. So we haven't really learned what data warehousing is, but let me just try to sum it up at a 100,000 foot view. And throughout the course, we'll be taking lower and lower views of this as we go. But data warehousing is really about empowering business users to make intelligent decisions with their data. And when I say a business user, I'm talking about a non-technical user, somebody who understands a specific domain of the business, but is not a technologist. I consider everybody in the class here a technologist. Right? We all know the SQL query language and how to join tables together. Your business users are not going to know how to do that. So how can we empower them to make educated decisions with their data when the data that they usually have to access is complicated and highly normalized and extremely structured and comes from multiple sources? So data warehousing is all about making it easier for users to get at their data, get the information out of their data, despite the challenge of the fact that the source data is usually in a complicated and non-conducive format. So a good way to kind of phrase that is to look at some questions. So these are typical business data questions that someone might want answered. And normally, how would you go about answering these kinds of questions? You write a SQL statement, right? So when was the most recent login for Remote Lab, or on which days is Remote Lab full? Right? These are common questions that you might want to know if you were a business user, and you shouldn't have to write queries to answer these questions, or you shouldn't have to ask the IT department to write you a query to answer these questions. You should be allowed to explore your own data and find these questions out yourself if you're a business user. One really key thing to note is that how you craft the select statement, you say select from, where, order by, the way that the SQL engine processes that statement is not in the same order that you write it. And this is confusing to rookie database people because they don't understand that the query engine is actually handling their command in a different way than they are structuring it. So what you want to know is that the first thing that happens is the from clause. So you're joining tables together, that happens first. Then where filters your rows. Then you select the columns, then the data gets sorted. When you understand how it actually gets processed and the order it gets processed, you'll become a much better query writer. So let's try some examples here, and let's figure it out through some data profiling. So on which date was the remote lab full? Let's see if we can answer that question. Data profiling is all about getting to know your data. And one of the first things that you need to do when you're profiling data is identifying what the business key is. You need to understand what one row in your data set that you're looking at. Here's my data set here. So what does one row in this data set mean? I need to understand that before I can continue. So it looks like I have an event ID, and then an event name, and then a net ID for a person, and then the computer that they used, and then a date timestamp and a pool name. And I can see that there's an event name shutdown, but are there other events? Yeah, there's startup events and reserve events and clear reservation events. So one of the questions I have is there a lab full event? Now I could sit here and roll through all these and look for a lab full event, or I could write a query that just shows me the different events that are there. This is the essence of data profiling. Programmatically explore your data source. So let's do this. Let's say select distinct. event name. Run that. Okay, and there is a pool full event. See that? So now maybe I want to see just the pool full events. So I'm going to take this out. Let's see these pool full events where event name is pool full. All right, those are all the pool full events. And let's get the most recent pool full event. So at the time of publishing of this video, there was a pool full event on 4/29/2015, 6:51 p.m. The original query asked which dates was the remote lab full. And you can see now that what I'm talking about, data warehousing, the goal of data warehousing is to make the data easy to explore, but the challenge that we have is that the source data has date and time put in here, and I only care about the date part of that, and I only want unique dates. So if I try to be fancy here and just say, give me distinct date timestamps, right, from here, the problem is that 429 repeats because the lab event full happened at several times on that day. This is one of the unique challenges of source data and why we build a data warehouse. And when we actually build this in a data warehouse, what we will do is we will split out dates and times, and then this date will reference a date table so that we can easily figure out if this was a Monday or a Tuesday. And then for this time, it will reference a timetable so we can figure out more information about the time. And then it becomes easier for the user to explore things like, does pool full happen on a Sunday or a Wednesday the most? It would be very easy to answer that. But with the way the data is now, it's very difficult to answer that. All right, let's kick it up to level 2.0 and look at joins now. In the join command, you're taking two data sources that could be tables or views, and you're connecting them together on usually a primary and foreign key pair, but it really could be any two columns that are join compatible, that is, they're of the same data type. But ideally you want to join columns on two columns that make sense. So usually it would be some kind of primary and foreign key. What you're looking at here is called a natural join. You join these two based on where they equal each other. But there are other types of joins. There are the outer joins. So there's a left join, which is represented here, A, B, and then this is a full outer join, and that's a right join. And the difference between lefts and right joins is that they include not only this middle portion here, which is part of the equijoin or the natural join, but they also include all the data from set A or table A. So these are different kinds of joins. Again, here's the natural join. There's a left join. Over here is a right join. These are various joins where you exclude out the portion of the equijoin. So let's do an example that involves a join. What is the GPAs? What are the GPAs of the last 10 students who logged into Remote Lab? Let's give this first one a try. All right, well, here I am back in SQL Server Management Studio, and I want to know what are the GPAs of the last 10 students who logged into Remote Lab. Here's my Remote Lab events. And one thing that you can see in here, well, there are nulls right here, but let's pick the logon event where event name is logon. So those are just people who have logged on, and these are their net IDs. And I told you this data was anonymized, so all you know for sure is that on 5/30/2014 at 12:50 p.m., somebody logged into Remote Lab and they were reserved on computer H04 in Pool IST. That's the user, but you don't know what their real net ID is. But we can use this as a key to join with another table, and let's do that. So join external sources, DBO. There's a students table in here. And I want to join that on, and I'm going to alias these, so I'm going to call that E, and that S. And it's always a good idea to alias your tables or views when you're building a select statement, because you never know if this source or this source are going to have the same column name in it. And if they do, then you have to disambiguate those columns, so it's just easier to start out with an alias. So now I could just say E dot, and E dot refers to all of this. It just makes my life easier. So E dot hash net ID equals S dot, and I wonder if there's a hash net ID in there. And there is hash net ID. Okay. Now there's a danger in doing this, and the danger in doing this is that we are assuming that this data here, we're assuming that one of these tables, for one of these tables, we're assuming that hash net ID is the primary key of one of those tables. Is that a correct and valid assumption? My guess is no. And what I'm going to do is I'm just going to execute this query to start. Make sure we get some data. And you can see now it's taking a long time to run this query. And this is one of the real challenges of data warehousing and profiling, is that you're touching live data. And remote lab events comes from one database on campus, and IST students comes from another database on campus. And when you simply join these together, now you're consuming a lot of memory on the server to make this happen, and this gets ugly rather quickly, as you can see. So hopefully it will execute this query in a reasonable amount of time. I'm going to pause the video until it's done because I want you to see how long this takes. All right, it's finally showing me data, but the query has run for 1 minute and 56 seconds. Almost 2 minutes and counting here. It's still going, and it's now starting to show me data. And if I really paid attention to this data, I would recognize that it is duplicating the data, and I really have not thought through this query very well. And this is the number one concern that you should have when you profile data, is you need to know each of your sources. Mainly, you need to know what one row means and what is the business key. If you don't know that, if you can't answer that, then you can never write this statement correctly. You can certainly have it return data, but the data that you'll return is not accurate. It is a misrepresentation of what is actually going on. And that is probably the worst thing you can do as a technologist, is give a business user inaccurate data with the assumption that it is accurate. There's a couple ways that you could fix something like this if you were working in the real world. Obviously, you'd have a data dictionary. You can talk to some people who use the data. But in this course, you're going to have to do some sleuthing. You're going to have to figure this stuff out on your own. And this is good for you. It's good practice for you. And that's really what it's all about, is giving you practice, helping you sharpen your saw and become better at this. So let's take a little tangent here. I'm going to, let's take a look and try to understand what this data source is all about. So I'm going to take that, and I am going to just comment this stuff out. It's all good, but we can't use it right now. And it's still actually running the query down here. And what I'm going to do is, let's just start looking at this other data source and try to figure out what makes it tick. So you'll see that I have term, net ID, SUID, GPA, and then some demographics about the student. And these have all been anonymized, so don't worry about finding yourself in here. It's not going to happen, because what I did was I took a look at the gender mapping of all the students, and, like, for example, maybe 60% are male and 40% are female, and then I completely remapped everybody randomly, based on the probability that you're male or female. Same thing with these other things like citizenship and, academic career description and your major. I remapped everything so it would be impossible to find yourself, but the data is still pretty realistic as far as representing someone. So how do we figure out what makes this data tick? You have to figure out what the business key of this data would be. How do you go about doing that? Well, you might say, well, maybe net ID is key. So one quick and dirty way you can figure out if it's a key is you could sort it, right? You shouldn't find two of the same net ID in here if it's unique. So let's do that. Order by hashed net ID. Let's see what we get here. Now, you run this and it's like, bam, it's taking a long time. But as you can see, it finally did run after 12 seconds, and there are repeats here. So the net ID does repeat. See that? And what you notice is that there's a different term for each one. So let me see if I can help you understand this data. But I believe what makes each row unique is the combination of term and net ID. And let me explain it to you. This is what this student looked like during this semester. This semester is fall 2014. This is spring 2015. That's what the student looked like that semester. So you're getting a view of what the student looks like in each of the different semesters. And a good example of that is their GPA might change. So you could probably find somebody in here whose GPA did change from semester to semester. Here's a good example right here. So this student's GPA did change from one semester to the next semester. Students that their GPA does not change, they didn't take any courses, obviously, for credit, and that's why their GPAs didn't change, but they're still active students. Okay? So now that we know that we don't want to pick every single student with net ID because then it's going to repeat. So if this student here logged in once, they're going to, when we join them, they're going to be in there 4 times. So the number of logins is going to be misrepresented. So to validate my point, if I pick a particular student, like that one, and execute the command, you'll see when it runs that this student has varying GPAs, and they have several terms. And this is the status of what they were like as a student in that term. So the data is different for each term. So the combination of these two makes a student unique. So if I were to take this hash net ID here, and let's go back to our original query, just to prove the second point. If I go down here and say and e dot hash net ID is that, you'll see that this person is going to log in several times. To give you a little flavor of what's happening here is if you look at the exact same date and timestamp, this person has logged in several times. And how is that really possible? It's not. And the other thing that should give it away as evidence is that there should only be one login event ID, but the event ID appears 8 times. Why does it appear 8 times? Because this person has 8 rows. This ID is in the student's view 8 times, 1 for each semester. So I need to actually pick the semester that I want to reference the student. And what I'll do is I'll pick the most recent one, which is going to be 1152. You'll get to know these term codes, and there's actually an external sources view that associates the term code with a friendly term like fall, spring, or summer. I'm going to add this in and run it, and now I should get an accurate number of logins. Let's see what we get here. Okay, so if you look, each ID is unique, and that corresponds to the event that happened with Remote Lab, and then this is the student. Now I would argue that this data is still not accurate, because if this student logged in, like they logged in 2014 in December, why should I use spring 2015 as the semester? This was not their GPA when they logged in. It was a different GPA. Okay. So what I really want to do is find the dates that correspond to the right term code and then use the right term code. That's a more complicated select statement we have to write, but we're not there yet. We're not going to write that quite yet. Okay? So for now, this looks pretty cool. This at least tells me the logins, and then I can get the GPAs. So now I can finish and actually solve the original question, which was the GPAs of the last 10 students who logged into Remote Lab. So now I can just say, give me the, let's say, S dot sum GPA. And let's also include E dot DT stamp. And let's get rid of that where clause. That doesn't make any sense anymore. And then let's order by DT stamp, descending, so the highest are first. And then we only want the top 10. This query might take a while to run, which brings me to my next point, which is every time that you run this, you are connecting to a remote database somewhere else on campus and drawing from this real-time data and drawing from this real-time data, then joining them together on this SQL server up here. So you're chewing up the memory on this SQL server to do the join, but the actual query, when you say select from this, it's actually running a select on some remote server that's getting it. And so this is not unlike what happens in the real world when you have data all over the place and you need to combine it together, because one of the goals of a data warehouse is to join disparate data sources together into a unified source. So how can I make this query perform better, especially when I'm exploring and profiling the data? Well, it took a while. It took 5 minutes and 26 seconds, but the query completed. Now you can see the GPAs of the top 10 last logins. This took a long time, so how can we make this run more quickly? And so that is the next kind of thing that we should probably discuss. And the way to do that is you recognize that this is querying on another server or another source. Could be a mainframe or a mini computer, or could be a data file, or could be a stream output from a log. And recognizing that if you import that data set into the SQL server and then query it, it's going to be much faster. So the way to do that is by using the select into pattern. If I said select star into, and this is going to drop it in my stage database because that's what I'm into, I am going to take the students one. So I'm going to call this stage students from that. And I could just do that. That's probably good enough, although you could put a where clause on there and just pull out the current term that you want. That might work better. But let's just try this out. I'm going to run this statement, and that's going to query the entire student source and then, in effect, dump it into a new table called STG students. And it did that. And you see it only took 9 seconds to do that, and it dropped 123,000 rows almost into that table. So now I can, from external sources, join, and instead of using IST students here, I'm just going to use STUD students. Like that. All right, let's see how much more quickly this query will run now that I've done that. And it ran in 1 second now. So that just goes to show you that there's no harm in copying the data when you're doing your profiling, because when you copy the data into the local database, it will allow you to work much more quickly with the data, because now the row retrieval and the joins are all being done on the same server. If I find the stage database here and look under tables, and you'll see that I should have stage students there. There it is. Okay. And so it made the table, and so it assumed which columns and data types to do based on the source data. So that's sort of how that works. And it's much better. So if you ever have a slow performing query, you probably want to do exactly what I did there and use that select into pattern. Level 3.0 of the select statement introduces aggregates, and where aggregates are different from what we've been doing up to this point is that the aggregates are a summarization of rows. So rather than returning physical rows in the data set, you're returning a summary of those rows. And this introduces group by and having. And group by is what allows us to select which columns to group by and then perform some kind of aggregate operator like count, min, max, sum, or average over another column. And then having allows us to filter that data after it's been grouped. So it's like the where clause, but after you've aggregated your data set. So to kind of show you what the full select statement looks like, we say it like this: select, top, from, where, group by, having, order by. But in essence, it gets processed in the order that you see on the right. First is the from clause with all the joins. It makes one big virtual table. Then we filter out the rows with where. Then we collapse those rows with group by and do our summarizations. Then we filter those rows with having from that result set. Then we project the columns, we do the sort, and we do top and distinct. If you understand that it processes in the order on the right, even though you write it in the order on the left, you'll be much better and efficient at writing your queries. So as an example, let's try to write how many undergrads freshman, sophomore, junior, senior used remote lab last semester. And by last semester, I will use fall 2014 or semester 1151. So let's go try and do that now. Okay, here I am in SQL Server Management Studio, and I could do my select from external sources, DBO, the remote lab events, where I'm going to alias this as E dot event name is a logon. So when you log on, that means you're using it. So that's when I interpret used, I mean they logged on. And now if I want to get grads and undergrads, I need to get students again. And rather than go to external sources, which I know is really slow, I'm going to use my stage table. Join stage students S on E dot hashed netid equals S dot hashed netid. And I also need to pick the right term so that I get the right number of students, and S dot term is 1151. Okay, so that gives me a list of everybody that has logged in. And now I just want to get the undergrads. So that is academic career. It says grad, and then UGRD is undergraduate. So I'm going to say where academic career is UGRD, like that. Oh, and silly me. So those are just the undergrads. Now what I want to do is I want to get a count of their logins, and I want to group by their freshman, sophomore, junior, senior, which is this one, academic level begin term description. Academic level begin term description. So what I want to say here is S.academic level begin term description, and count the rows, count star as logon count. I'm going to alias that column so that it shows up with a nice name. That does not execute because whenever you introduce an aggregate operator here, you need to use a group by. And you always need to group by the columns that you are not summarizing. Like that. And there we go, freshman, junior, senior, sophomore. Now, one of the things I don't like about this is they're not in the right order. It should be freshman, sophomore, junior, senior. And if you look, there's another column here called S.academic level begin term. I'm going to show you what this one is. This is the code. This is what profiling is all about, knowing your data. There's the code. Now, if I order it by that, then I'll have what I want, which is freshman, sophomore, junior, senior. Maybe I want to filter out the unclassified. Now, I can do that a couple of ways, right? I could use the where clause, but I could also use having. If I want to take what I see here and then filter it with the where clause, I would use having. So I could introduce that as well, just for an academic exercise. Let's say having logon. Let's say having academic level begin term not equal to 70. There. So we have freshman, sophomore, junior, senior. Login count. There we go. Solve the problem. But you can see already how messy the SQL statement is becoming, and it's now crossed the level where the average business user is not going to be able to create a query like this. And so the promise of data warehousing is to restructure our source data in a manner that you can easily query the data without having to write a very sophisticated SQL statement. That's the goal, if any SQL statement at all. If we structure the data in a predictable way, then we can use tooling to browse the data, like an Excel pivot table, if you will. So one other thing that I bring up, because it's something that may happen to you during the course of the semester, is you might require to use a subselect. And all this is using the full power of the select statement in either the row, the column, or the where. And you can build a subselect that, for example, does a select from, rather than selecting from a table, you select from a select statement. You can also do a select statement, but you put the select statement in the projection or column. And you can also put the select statement in the where. So you could say select from one table where a column has a value that's in some select statement that returns a value. So you got to think about using this in situations where the straightforward one single unified select statement doesn't solve your problem. Rather than use the examples you see on the slide here, I'm going to use the previous example to demonstrate where a subselect would make a lot of sense. So in this final example, what I'd like to do is, see these login counts here? I'd like to take the average of these login counts. So I could do this math manually. I could take 81 plus this, plus this, plus this, divide it by 4 and get the average. Or I can use the select statement to do that. And the way I would do that is if I treat this like it's a table, I can then run a select statement over it that does an aggregate on this to compute the average. So let's imagine that this here is one big table, right? So I'm going to do this. I'm going to say select from, and then this is going to be one large table. And I'm just going to indent everything. It really doesn't make sense to sort it because it's just a big table. And I'm going to call that X because I'm uncreative. So what I'm doing is I'm running a select statement from, and then this is going to be my table. So I execute that, and now I could do this. I could say select average of logon count. As average logon count by academic level. And there's your answer. And if you check the math, it's right. But this goes to show you that you can create a new select statement using the output from an existing select statement. And this existing select statement can be in the projection line. It could be up here. It could be after from, so treat it as a table, or it could be within the where or the having clause as well. And typically when we do that, we use the in statement, so where in this value. So as I sum up this lesson, one of the things that I demonstrated was how to handle slow querying processing. And this is going to be important as you're doing your own data profiling. You might encounter one of these sources that's kind of a little more sluggish than the other. And the easiest way to do that is to use the select into pattern. When you say select star into new table, it's going to create this new table for you here. This is going to be added to the database schema as a new table. And it's going to use the columns that you project to be the columns in the new table. And if the table already exists, you just have to drop it first before you can run this. Another pattern that you can do is you can do the insert statement, but this table has to exist already. And then rather than inserting values, you can insert the output of a select statement. This is another way to do it. The advantage of this second method is that you can create the exact table you want, set up the primary keys, set up all the indexes, etc., get the schema exactly the way you want, and then fill the data from the select statement. The top example is the perfect way to create a new table from the output of a select statement. And that's usually the pattern you want to use when you're doing some data profiling. Just remember that these are temporary solutions, and you just use them mainly for profiling. When you actually are starting to build your data warehouse, you don't want to use these tables because they are copies and they won't have all the updates. They're only going to be as responsive or as updated as the last time that you ran the select into new table. All right, so in summary, remember, we're trying to empower business users, but the data sources are usually from multiple areas in our organization, and they're highly normalized, and they're very difficult to work with. They're not in a structured format that's conducive to exploration. So what we need to do is we need to understand those data sources better, understand what one row in those data sources mean, so that we have a better idea how we can eventually reorganize that data with the goal of making it easier for end users to query it themselves. And over the course of the next few weeks, you'll learn exactly how to reorganize that data into dimensional models so that end users can explore the data on their own. All right, we'll talk to you soon then.